So in this video, we will illustrate um, how to write a C program that's going to achieve these goals here. So if we want to read multiple records, and for this demonstration, let's just say example three records, and each record is going to read names and ages for each record. How do we write that program? So there are like multiple ways of doing that, right? The most simplest way, and obviously not the practical way, is the simple variables, and that's a static memory. Second one is arrays, and that's, again, static memory. You have to define how many records you're going to take in. And 2 and 3 are pretty much the same, except that it's a little more fancier way to write it and easier to read and write data structures. And again, this would be static memory. But what if you want to do, you don't want to define the static memory. You want to go runtime and define the memory as much as you want while you're running the program, and that's pointers. And then you're going to use dynamic memory to allocate as many records as you want. But again, for this demonstration purposes, we're just doing 3. But let's take a look at these programs, and that will hopefully help you understand when to go from a simple variable to an array to a data structure and then to a pointer. Right, so let's take a look at the first example, and that is our simple arrays. So this program is here, takes 3 records, name 1, name 2, name 3. Each one is 50 characters, and each record has an age 1, age 2, age 3, 10 characters. And then we start the main program, and we enter or get the first name, and we're using the gets function, which is specific to Windows here. It's not supported in C11 compilers, Linux based, where you're going to have to use fgets, or you're going to have to use scanfs functions. But for simplicity's sake, let's just use the gets function here, and it's going to get the first variable, name 1. Repeat this 3 times with name and age, name and age, name and age, name and age. That's the basic simple way. So you're taking 3 records. Now imagine if you have to take hundreds of records, you're going to have to repeat it. We can't use the loops because we're not using any variables in this. And that will take us to the second methodology, where we want to put this in a loop fashion instead of writing the same statement again and again. And then in the end, we print all of that, right? So let's take the same program and write it in a loop. So we use arrays for that. All the programs here are doing exactly the same thing, okay? And in this format, we're using an integer I for our looping index or variable, and then we defined the record or the variable names in a 2-dimensional array. So, and the S is defined to be 3 here, which is a constant because we're using the example here for 3 records only. So if you want to use 100 records, million records, you can just put that here. And it's going to pre-allocate that much memory, but you need to know the number. That's the drawback, was fixed size of number. So names, multi-dimensional array with 3 records, 50 character each, and age exactly the same. And you go into a loop now. You're going to use a for loop with the I character or I variable, 0 to 2, which is 3 together. And we're going to increment by 1, plus I. And we're going to enter the statement, print statement asking for the name and the age. We're going to come back and do this 3 times, and then we're going to print this. So exactly the same program. Here we repeated the get statement and the print statements. In this one, we're just repeating in a loop. So both the programs are achieving the same thing. Here, we didn't use the loop, but here we're using the loop, and therefore we're using a multi-dimensional array here, two-dimensional array to go in the loop. All right, and let's stop here for a second and let's run the first two programs. And if I go and do CL, this one is called just vars. So if I do just vars and then run just vars exe, name one is, let's just say ABC, age is 1, name 2 is EFG, age is 2, name 3 is IJK, name age is 3. So here's your output. You enter name 1, ABC, EFG, IJK, and their ages. So that was the first program. Let's run arrays. We do compile. Okay, and then we run this program. Enter name 0. Now it's giving me the the variable starting from 0. So ABC 1, EFG 2, IJK 3. You enter names ABC, age 1, so on and so forth. Exactly the same output, except that we're using an array, multi-dimensional array. So here's the two formats of these programs. One is going in a loop fashion with multi-dimensional arrays, and the other one is static, as static as it could be. So now let's go to the third option, and that third option is data structures. Now we're going to achieve the same goal, but with data structures. And we are going to define, again, all of these programs are doing exactly the same thing. So we define, we're going to use an array, and we're going to use an array of 3 records, and we're going to use I for our looping. But here the data structure is defined as S1 or whatever name you want to give. And the name and ages are defined as usual, as in previous programs. But we're going to call this records, and record of 3 again. And the problem with this program is that you have to know how many records you're entering. So we get into the same loop, we get the names, we get the records, and we print the names and the records in this fashion. It's just notice how the get statement is written here and how the get statement is different here because we're using data structures. It's exactly the same. This is multi-dimensional arrays. This is data structure. This is much more easy to read and write compared to multi-dimensional arrays. So print statements is also pretty much the same, except that you reference the records and then the element inside the data structure. Okay, so that's your third format with static memory. Let's run this data structure program. Okay. ABC1, EFG2, IJK3, and you get exactly the same output as the first two programs. The only difference was, again, you use data structures in this one where you define sort of a table. Both the programs are same, different ways to do it. I prefer data structures because it's easier to reference and easier to write. Now let's go to the fourth one, which basically is different from the first 3. Why? Because it can allocate dynamic memories with pointers. So all of them, you have to define that the number of records you're entering, right? 3, 3, 3 in all the cases. Here we don't have to. We can allocate the memory dynamically. And let's see how that program looks like. Again, we're going to use structures, and inside the structures, since it's going to be a different data type and we're using pointers, we have to use the definition. So compare this guy with this one. Here we use structure simply, and in this one we're using type def. So we're defining a different, variable altogether that is called S1. Actually, we were defining a different variable that's called records. So we just use an extra keyword here, type def, structure S1, same elements in there, and records. Now here we don't define the number of records that we need. It's not static, so that's the good part. Then we use the pointers here. So this is a pointer. This pointer is basically a memory allocation. It's basically pointing to a memory allocation where this guy is going to be sitting. So we're going to use this, we're going to define this pointer, and this pointer is going to point to this data type, which is defined right here. And obviously the advantage of using the pointers is that now we can use pointers to dynamically allocate memory. So one of the use cases of pointers. There are so many different use cases, but this is just one. We get into the program, and we use I as our looping variable, and we use this function for memory allocation. Now this function is used for runtime memory allocation. That means when you are running the program, it allocates the memory as the program goes on. And so it doesn't need a predefined number of memory blocks like we did in the previous program. So this is how you dynamically allocate a block of memory each time you enter the record, or each time you're making an entry. So this is dynamically done at runtime. We get into the same loop, and here's how you reference pointers. You basically enter the name, use the same function, and this is how you reference a pointer. You use an arrow with a dash. And so the reason I'm doing pointer plus I is this is the first index of where the pointer is going to be pointing. This is p plus 0. So it's the first reference memory reference area. And then it's going to take the h, the same one, and then go back, add I to increase the index or I variable to 1, and it's going to put the pointer memory space to the next one, and so on and so forth. And then we print it like this using the same format. So let's run this program. And you may get this error, so you can, it's not an error, it's a warning, so you can ignore that. It's probably a Microsoft thing. ABC1, EFG2, IJK3. Exactly the same amount of, exactly the same output. All the programs are doing the same thing, except that the fourth one is much more flexible. It's allocating the memory dynamically and at runtime, and it's using, for that, it has to use a type def structure definition so that it can assign that data type to a pointer, and then you use that pointer for memory allocation. So that's the advantage of when or why you use these types of data structures and formats when you're writing a program. Obviously, for databases, you would use something like this. And if you have something predefined in terms of how much memory you're going to use, you can obviously use this one or this format. This one is just for learning purposes or illustrating purposes. It's not going to be practical for anyone to write every single variable and print statement repeatedly. But between these two or these three, the real difference is going to be obviously do you know how much memory you're going to need or records going to need, and you're going to define that at the start, versus if you want to do that at a runtime, you're going to use typedef with pointers and this function that's going to give you memory as you run the program. Hope this helps.